Okay. Um, okay. So let's start. So I already explained three rule. Now, rule 4, it say that if the given equation means we consider this our equation 1. Okay. So this equation 1, we can write in the form of y function of xy dx plus x into function of another function of xy dy equals to 0. Okay, dy equals to 0. And if n into x minus n into y is not equals to 0, then we can say the integrating factor will be 1 by mx minus ny. Okay, now try to understand this rule 4 with an example. Okay, now here if you check the differential equation and if you try to compare this differential equation y into one function of xy, because we consider this is a function of xy. Okay, each and every term we can write it's a function of xy dx plus x into another function of xy. Let me take this function as g of xy. Okay, in dy equals to 0, then this function is basically a function of xy, and this function is g of xy. Okay, so if you compare that, we can write this differential equation in this form. Okay, in this form. Now for this problem, we can easily identify that we have to apply rule 4 to find integrating factor. Okay, so it say that just you have to check this value is 0 or not. So let me multiply m into x and n into y. So it will be xy in bracket xy plus 2 x square y square minus xy in bracket xy minus x square y square. Okay, now just try to simplify this and you have to check this value is 0 or not. Okay, so it will be x square y square plus 2 into x cube y cube minus x square y square plus x cube y cube. Okay, now this term will be cancelled out and it will be 3x cube y cube. So it's very clear this value is not equals to 0. So we can say that integrating factor will be 1 by 3 x cube y cube. Okay, so I hope this part is clear. Now how to find general solution? It will be same as before. So therefore the general solution of the given ODE is integration m into integrating factor dx plus integration n into integrating factor dy equals to c. Here c being arbitrary constant. Now this term it will be x free, but in our integrating factor, since there is one x involved in integrating factor, so if we multiply any function with this integrating factor, then there is definitely x involved in this term. So we can remove this calculation, we can remove this part. So just we have to integrate the first part. Okay, so our function m is x into xy plus 2 x square y square. Okay, dx equals to c. Okay, and if we multiply this with integrating factor, it will be integration x square y into 1 by 3 x cube y cube dx, and the second term will be 2 integration x square, so not x square, x cube y square into 1 by 3 x cube y cube, okay, dx equals to c. So first simplify this. There is only one x square, so we can say 1 by 3 1 by y square integration 1 by x dx plus 2 into x cube y cube will be cancel out. It's 2 by 3 integration 1 by y dx equals to c. So it will be 1 by 3 1 by y square log of x plus 2 by 3 x by y equals to c. Okay. So we can also modify this equation in the form of log of x by y square plus 2 x by y equals to 3c. We can write c as here. Okay, so this is our general solution of the given ODE. Okay, so in this way we can solve this equation. If the given equation 1, we can modify this in the form of a to the power x to the power a, y to the power b, my dx plus nx dy plus x to the power a dash, y to the power b dash, m dash y dx plus n dash x dy equals to 0, where these values are all constant. Then our integrating factor will be x to the power h, y to the power k, where this a, B, A dash, K, H, M, N follow this condition. Okay, there are actually two different equations, that A plus H plus 1 equals to N equals to A dash, and B plus K plus 1 divided by N equals to A dash. Okay, so try to understand rule number 5 with an example. Okay. Okay, so here it's very clear to understand that we can write the given differential equation in the form of x to the power a, y to the power b, n into y dx plus n into x dy plus x to the power a dash, y to the power b dash, m dash y dx plus n dash x dy. Okay, now if we compare this equation, then the values of a, b are, so value of a is 1 because the index value here 1, but there is no y, so we have to consider this value, index value of y is 0. So therefore the value of b is 0, value of n is 4, value of n will be 2, value of a dash is again 0 because there is no term, so we have to consider that there is x to the power 0, b dash it will be 3, n dash it will be 3, and n dash it will be 5. Okay, now for this type of integration, sorry, this type of differential equation, we know that the integrating factor will be x to the power h and y to the power k. Just you have to find the values of h and k with this equation. So the equation is a plus h plus 1 divided by m equals to a dash, and the another equation is b plus k plus 1 divided by n equals to a dash. So let me put the values of a, b and m in. So it will be 1 plus h is unknown here. 1 divided by m, value of m is 4, equals to value of a dash is 0. So let me put 0 here. Okay, now for this equation, the value of b is 0 plus k is unknown. 1 divided by n, value of n is 2, is equals to 0. Okay, so if we simplify this equation, the values of h and k are minus 2 and value of k is minus 1. So therefore, the integrating factor will be 1 by x to the power 2 and into y. Okay, I hope this part is clear. Now we have to find the general solution. For that, we have to modify this equation a little bit. So there is one thing that in integrating factor, there is x involved in integrating factor. So don't need to calculate for this part, the dy part. Just we have to calculate for dx part. Okay. So from the given equation, if you rewrite this equation and we just calculate the coefficient of dx, so it will be 4 into xy plus 3 into y to the power 4, and integrating factors are 1 by x square y dx equals to c. So this is our general solution. So just you have to simplify this. So it will be 4 into dx plus 3 into y cube dx equals to c. Okay. So it will be 4 into log x plus 3 y cube minus 1 divided by 1 equals to c. So it will be log of x to the power 4 minus 3 y cube by x equals to c. So this is our general solution. This is our required general solution. Okay. So now let me explain another problem. Okay, so in this problem, look, the solution is not important. How to think, it's very important. Here, for any random given problem, um, you have to check that which rule is applicable to find integrating factor. Okay, because you have to find integrating factor. In question, they're not mentioned that which rule is applicable for that. So for this problem, first we have to check this equation is exact or not. So let me consider the first coefficient of dx is 3x squared y to the power 4 plus 2xy. Okay, and this function in is 2x cube y cube minus x squared. Okay, now if we derivative this function in with respect to y, it will be 12x square y cube and it will be 2x. Okay, and del in del x will be 6x square y cube minus 2x. Okay, I hope this part is clear. So definitely del m del y is not equals to del n del x. So therefore, if we consider this equation 1, so equation 1 is not exact differential equation. Okay, so we have to find integrating factor. Now here, this m, if we take y common from this m, this function is not a function of xy, and also if we take a common from this m, this function cannot be a function of xy. So it's very clear that rule 4 is not applicable for this. Okay, now you have to think in this way that is it a homogeneous function, means this m and n? So definitely not, because it's a x square y to the power 4, so the degree is 6, and for the next term the degree is 4, so degree is 2. So definitely it's not a homogeneous function, so we can't apply rule number 3 here. So now go for rule number 1 and 2 and check that which rule is applicable to find integrating factor. So now for that we have to check the difference of del m del y, minus del n del x. Okay. So it will be 12x square y cube plus 2x minus 6x square y cube plus 2x. Okay. Now if we simplify this, it will be, sorry. If we simplify this, it will be 6x square y cube and plus 4x. Now think in this way that if I divide this difference by n, is it a function of x only? Or if I divide this difference by n, is it a function of y only? Okay, so let me take n here and let me divide this difference by n. So we can take 2 common. So it will be x square y cube plus 2x. Okay. And if I take y common in m, so it will be, so sorry, and there is 3. So 3x square y cube plus 2x. Okay. So it will be cancelled out. So definitely it's a function of y only. Function of y only. Okay. So it's very clear that rule 2 is applicable for this problem. So therefore, the integrating factor will be e to the power minus integration function of y. So it's 2 by y dy. Okay. So it will be minus 2 log of y to the power minus 2. So it will be 1 by y square. Okay. So this is our integrating factor. Okay. There is no term of x, so we have to find the general solution. Now it's your job to find general solution, because in the previous problem I explained so many times that how to find general solution. Just check this video and try to find the general solution.